Okay, copy this guy down. This is our next example. If you look at your notes from the previous chapter, you'd see that this is previous two chapters. This is exactly what we did in those problems as well. We solved for KC, and then we used KC to solve for X. Same thing when it came to KA and KB. We solved for those first, then we used KA to solve for X. We're going to do the same thing here. I'm going to give you KSP, and you're going to solve for the actual concentrations of the ions in the solution. All right. Well, the problem's done basically the same way. You have to write the equation down, like always. Zinc hydroxide. I think I gave these to you. You'll need your common ion sheets to know the charges. Because if I look up zinc hydroxide, I look up zinc on the periodic table, I look right there, and he is in the middle. He's one of the transition elements. So I don't really know what his charge is. So some of you may remember some of these from Chem 1 because we used them a lot more back then. But zinc's oxidation number is +2. So zinc is a +2, hydroxide is a -1. So the ZnOH2S is dissolving in solution, in water, into zinc ions and hydroxide ions, aqueous. And I have to balance it. I've got 2 hydroxide ions, so I've got to put a 2 in front of the OH. And the weirdest part about this is it's different than the previous ones. Is I'm not specifically given initial and then 0 and 0 and the -x, -x, +x. All right. The amount that dissolves, the dissolved amount, is basically x, and it's going to be x here, and it's going to be 2x there. So I don't have to go through all the ice here, because I'm not talking about how much I actually added to the beaker. It's useless information. It's just the amount that dissolved. And the amount that dissolved is represented by x. Now, we already figured out the KSP equation is going to be zinc times hydroxide. There's no denominator squared. There's no denominator. It's just all one line, which makes my life a lot easier. Plug my numbers in. 4.5 times 10 to the -17th equals zinc's, which x, and hydroxide's 2x quantity squared. Now there are some mistakes you can make there. All right, 2x quantity squared is different from 2x squared. And that's what a lot of people do. I'll guarantee you, there won't be a class that a test doesn't happen on a test. They'll just do that, 2x squared. So when they do this multiplying, they'll have 2x squared times x, and they'll have 2x cubed. And that's not correct. What's the correct answer? 4x what? No. 4x cubed. I'll multiply them together. 4x cubed is 4.5 times 10 to the -17. Now, hopefully you all know how to, well, first of all, just divide by 4. So x cubed would equal what? 1 point something, 1.1 or something, times 10 to the -17. So 1.1 times 10 to the -17 is x cubed. Hopefully you all know how to do on your calculator, because they're all done slightly differently depending on your calculator, how to take a cubed root in this case, and how you would take a cubed root of 1.1 times 10 to the -17 and get x. What does x therefore equal? What did you get? 2.2. So 2.2 times 10 to the negative what? 6. Now that is your answer for the molar solubility of zinc hydroxide. That's the molar solubility. That's how many moles per liter. Okay? And that is your answer for the molar solubility. But I also want the gram solubility. So if I know I've got 2.2 times 10 to the -6 moles per liter. And I want grams per liter. All I have to do is moles in the bottom, grams in the top, 1 mole contains. And what am I going to use for this mass, though? I'm going to use the mass of zinc hydroxide, which would be 1 zinc, 2 O's, and 2 H's. So find the molar mass of that. That's what goes in the top. Somewhere around 99 grams, I believe. What is it? 99.403 grams. 404. Okay, multiply that out, and what do you get for your answer? What we get?
0.2 times 10 to the negative 4.
All right, so that's basically telling you there are only 0.00022 grams of zinc hydroxide in every 1 liter. When you can throw as much zinc hydroxide into the beaker as you want to, a 1 liter size beaker. Throw as much as you want to. That's how much will actually dissolve. 0.00022 grams. Something you couldn't even measure on any of the scales we have back there because they're not accurate enough to measure that amount. It's such a small amount. And that's because, and you would expect that because the KSP is such a small value. Yeah.
I got to the -8th power for that.
Try it again. 2.2 to the -6 times 99 is definitely not going to be -8. It's going to get bigger, not smaller. You're multiplying, not dividing. And it should make it bigger, not smaller, for sure. And by about 2 spaces, because 99 is approximately 100. So you should make it 2 spaces bigger, basically. All right, which would be -4. Okay, that's it. That's all I have for today. The homework is on the board. 14 to 16 are the same kind of problems. You're going to find the molar solubility. You should have time to finish most of those up in a shortened period anyway.
How did you do that to the 3rd power?
Again, every calculator is different. I don't know. Let me see yours. I can see if I can figure it out. I'll have to look at it and see. Anybody else, first of all, have a calculator like this? Here, how did you do it on yours? Go here, show.
Okay, you press, like if you're doing the cube root, you do 3 and a second this right here, and then go to cube root and then plug in the whatever you want.
3, and then a second.
Second, this one over here.
And then the caret. So that's going to inverse what the caret is the power of. So let's just try that. So basically the cube root of 8, let's clear this. So 3 seconds at 8 would be 2. That's right, that works.
Good job, Vic. Coming up clutch today, man.
Are you using the 1.1? Yeah.